All right. Number 14. So find the points where the tangent line is horizontal, right? And when it says points, this could be like a single point or multiple points, right? So let me just write this here. It should say point like that, right? Find the points where the tangent line or the function is the tangent line is horizontal, right? So remember tangent line. When we think of tangent line, we're going to think of the derivative, right? So in this case, we have y. So tangent line is going to be y prime or dy dx, right? Okay. And horizontal, that's where, remember, horizontal lines have zero slope, right? So we want to know where is the slope equal to zero, aka, remember, slope of the tangent line is the derivative, right? So we're saying when is the derivative equal to zero? All right, that's what we're looking for. So that's the decoding part right here, right? That's how to interpret the directions and use calculus to figure that out, right? How to like think about when you're seeing this stuff, what have we learned in calculus that helps us to find the slope of the tangent line, right? So we know where it's going to be zero, basically where it's horizontal. All right. So first we're just going to take the derivative of this. So dy dx or y prime. Okay. And so that's hopefully pretty simple for you. Just some power rule here. 2 times 2. Subtract 1 from the 2 there, right? And then the derivative of 4x is just 4, right? Derivative of negative 3 is 0. All right, so we get that. And we set this equal to 0. And so we get, and I'm going to, as I set it equal to 0, I'm going to factor this out, right? So I'm going to just factor out a 4. Actually, we don't have to do that. This is just a linear function, so we don't really have to factor. So then I'm going to just subtract 4 from both sides. So we get negative 4 equals 4x. Then we divide both sides by 4. And so we get negative 1 equals x. Okay? And so it says find the points where the tangent line is to the function is horizontal. So this is the x value. And if we want to find the point, like the coordinate point, then we're just going to plug in negative 1 into the original function, right? So what I want to do is just find basically y of negative 1. So I'm just going to do 2 times negative 1 squared plus 4 times negative 1 minus 3 to get the output, to get the y value. So, so that becomes 2 minus 4 minus 3, which will be negative 5, right? So when our input is 1, our output is negative 5. So that's our coordinate point. That's the point where the tangent line of the function is horizontal. Okay. All right. So this is a bit of the, kind of stretch challenge category here with this problem. We had one like it. I'm trying to think of what lesson it was on. It might have, yeah. But anyway, I can point that out in class. Let me know, but or email me if you can't find it. But yeah, but just know when a tangent line is horizontal, we're asking for where the derivative equals 0, right? So find the derivative, set it equal to 0, solve, and if it's asking for the point, don't forget to also find the y coordinate of that point.